This is a revision video for Algebra as part of the Leaving Cert higher level material. We're going to be looking at the discriminant, the quadratic equation formula, some u-substitution, simultaneous equations with a line and a quadratic, and then finally solving algebraic fractions. So I'm just going to show you the 4 questions that we're going to look at before we start them. So these are the 4 questions. If you want to maybe just take a picture of them or take them down before we start, and we're going to go through each one separately. So the first one we're going to use is our discriminant. Question 2 we'll use the u-substitution. Question 3 then is our simultaneous equations, and the final question we look at is our fractions with algebra built into it, and we're solving the equation in question 4. So a bit of work involved in these. So let's have a look at question 1 first of all. So here it's asking us to find the values of k, so make sure there that you spot that there's more than one value for k, values of k, if the equation given there has equal roots. So the key to this question here is that it's telling us that it has equal roots, so that's drawing my attention there to the discriminant, and when it has equal roots, the discriminant is equal to 0. So our discriminant is the part of our quadratic equation formula, and we focus in on specifically the b squared minus 4ac, and when it's equal roots, it's equal to 0. So that's basically what we need to examine as part of this question. So before I fill it in, I need to write down what my values for a, b, and c are. My a is always the value or the coefficient of the x squared, the number in front of the x squared. So in this question, it is k squared. My b is the coefficient or the number in front of the x, which is 2 times k plus 1. And my c is the constant, the number on its own, and that is positive 4. Remember that we don't obviously take the x and the x squareds with it. Now I'm going to fill in my quadratic part, my b squared minus 4ac equals to 0, and solve that. So my value for b is 2k plus 1. So I'm going to sub in my 2 bracket k plus 1. I'm squaring that, so I'm going to just put that into a bracket, another bracket, and make sure that I have to square it. I'm now going minus 4 times a. My a is k squared, and then I'm multiplying that by my c, and my c is 4. And that is all equal to 0. I'm just going to evaluate that part that's in the red bracket. So I'm going to multiply in my 2 into the bracket here. And that is giving me 2k plus 2. And now I need to look at squaring all of that. And then when I evaluate the 4 multiplied by the k squared multiplied by the 4, that is giving me minus 4 by 4, which is 16. And 16 by k squared is 16k squared equals to 0. Now I'm going to come back to the 2k plus 2 all to be squared. Basically what that means is when something's squared, it's multiplied by itself. So I'm just going to do out my 2 brackets there. And what I'm multiplying out is my 2k plus 2 multiplied by 2k plus 2. Then minus my 16k squared equals to 0. When I multiply out my brackets, first term by second bracket, so 2k multiplied by my second bracket, which is 2k plus 2. Then my second term, which is plus 2, times my second bracket. And don't forget, that is all minus 16k squared equals to 0. 2k multiplied by 2k is giving me 4k squared. 2k multiplied by 2 is giving me 4k, so a positive, a plus 4k. Then I'm on to the second bracket, 2 multiplied by 2k and 2 multiplied by positive 2. So that's giving me a plus 4k once again, and 2 by 2 is 4. Again, minus my 16k squared. Don't forget that, that has to come down all of the time. Now I'm going to group like terms. So if it's 4k squared minus 16k squared, that's giving me minus 12k squared. I then have a positive 4k plus 4k, which is giving me positive 8k. And then I have my constant, my plus 4 is equal to 0. So basically what it's getting me is another quadratic equation. But now in order to solve for k, remember if we go back to the question says that there are 2 values or values for k. So when I do my two brackets here or a minus b formula, you will get the two values for k. So it's up to you, practice your brackets, your trial and error method, but I'm going to use my quadratic equation formula for solving this. So I'm going to bring up my quadratic. It's minus 12k squared plus 8k plus 4 equals to 0. Now, be careful here now, we're doing our full quadratic equation formula. So we're not only doing the discriminant part, we've done the discriminant part here on the left. We now have to do the complete minus b formula in order to solve for k. So my formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula from my log tables. I'm now just going to write down on the side here the values of my a, my b and my c. My a is the number or the coefficient in front of the x squared, or the k squared in this case, which is minus 12. And my b is the number in front of the k, which is 8. And the constant is the 4, which is the value of c. And I'm just going to sub that in now to my formula. So instead of a x, it's going to be a k. So k is equal to minus b, which is minus 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a times c, and that is all over my 2 times a, which is 2 minus 12s. And I'm going to evaluate that, and that is giving me k is equal to minus 8 plus or minus the square root of 256 all over minus 24. And the square root of 256 is 16, so it's k is equal to minus 8 plus or minus 16 all over minus 24. Now I'm going to focus in on this plus or minus part, so I need to do it out for the plus and do it out for the minus. So k is equal to minus 8 plus 16 all over minus 24, and k is equal to minus 8 minus 16 all over minus 24. So therefore, my two values for k are minus 1/3 and k is equal to positive 1. And that's question 1, using the discriminant and the quadratic equation formula. Let's scroll down now and have a look at question 2. So question 2 is asking us, by using suitable substitution, solve the following quadratic equation. So it's quadratic because it has a power of 2. That's the giveaway here. And then it goes down to degree of 1 and then a constant. So that's telling me that it's a quadratic. Now we don't solve quadratics when it's looking complicated like t minus 6t or 6 over t. So what I'm going to do there is I'm going to substitute u in for t minus 6 over t. So I'm taking my t minus 6 over t and I'm going to change that or substitute that in with a letter, and I'm going to call it u. Now you can call it any type of substitution. You can use any letter to represent it. I'm just calling it u. And then when I sub that into my quadratic, I'm now changing what's inside the brackets and I'm changing it for the letter u. So I'm just substituting in u instead of t minus 6 over t. And you can see here now that this is basically a quadratic equation. We're used to looking at it with x's, I just have it with a u. And all I have to do now is solve that. So I can take out the brackets there, so that's u squared minus 6u plus 5 is equal to 0. And what I'm going to do now is I'm going to solve it. I don't need to use my minus b for this one. This is quite straightforward to do. So what are the numbers that multiply to positive 5 and add to negative 6? That's giving me a u multiplied by u, and that's giving me a minus 5 multiplied by a minus 1, because minus 5 by minus 1 is positive 5, and minus 5 take away 1 is minus 6. So therefore, u minus 5 is equal to 0, u minus 1 is equal to 0. If I add 5 to both sides or move the 5 over, I get u is equal to 5 and u is equal to positive 1. Now unfortunately we're not finished, because we now have to come up and solve for t. The question wants us to solve for t in this particular question. and I need to do it out twice for both answers that we achieved for u. So therefore, I'm now going to have, I'm bringing back up my t minus 6 over t is equal to u. And I'm now going to change that to t minus 6 over t is equal to 5, because that's the answer I got for u. And I'm going to do that again. And I'm going to go t minus 6 over t is equal to u. This time I'm subbing in my positive 1 for u. And I'm solving this. Now I have 1 on the bottom, or sorry, t on the bottom of my fractions now. So that's the same as me putting these over 1, t over 1, 5 over 1. And I'm going to multiply across by t because my common denominator here is t. So I'm going to multiply across by t. So that's giving me t squared. So I'm multiplying by t, multiplying by t, and multiplying by t. So that's getting me t by t is t squared, t by 6 is 6t, but I divide that by the bottom, the denominator of t, which is just giving me minus 6, is equal to 5 by t, which is 5t. And I come over and I do the exact same thing for the other side. I put them over 1. Common denominator, once again, is going to be t. So I'm multiplying across by positive t. And t by t is giving me t squared. T by minus 6 is minus 6t divided by t, which is minus 6, equals to 1t. I'm going to move everything to the left-hand side of the equal sign because I want my quadratic equations to equal to 0. So this is giving me t squared minus 5t minus 6 is equal to 0. And same with my other quadratic. If I move over the minus or the positive 1t, it's t squared minus 1t minus 6 is equal to 0. And I now have to go off and solve those two quadratics once again. Again, they look straightforward. I don't think I need my minus b formula. So I'm going 2 brackets equal to 0. 2 brackets is equal to 0. And I have t multiplied by t is t squared. And once again, I'm looking for two numbers that multiply to minus 6, add to minus 5. That is getting me minus 6 by positive 1. Minus 6 by positive 1, does that work? Minus 6 by 1 is minus 6, minus 6 plus 1 is minus 5. So that does work. So what are my two solutions for t? T minus 6 is equal to 0, so therefore t is equal to 6. T plus 1 is equal to 0, t is equal to negative 1. And don't forget I have my second quadratic over here on the right hand side. So two numbers that multiply to negative 6 add to negative 1. And that is minus 3 and a plus 2. Minus 3 multiplied by 2 is minus 6. Minus 3 plus 2 is minus 1. So therefore, I have t minus 3 is equal to 0. T is equal to positive 3. And t plus 2 is equal to 0. And t is equal to negative 2. So therefore, my four solutions for possibilities of t are minus 2, minus 1, 3, and 6. And they are my final solutions for t. And that is question 2. If you want to check your answers, all you have to do is sub them in for t in the original quadratic, and you should get 0. But I'll leave that up to you to check that. So question 3 is asking us to solve the simultaneous equations. And you can see here that we have one being a linear, so there's no degrees of 2, no powers of 2. And then the second one has degrees of 2 in it. So we have a line and some sort of quadratic or circle going on here, some sort of curve. So what we first of all do is we take our equation of the line, and what we do is we now manipulate our equation of the line so that it is either in terms of x or in terms of y. So what I'm going to do here is I'm going to go x is equal to minus 5 minus 3y. So I'm bringing over the positive 3y. Now you can have it y is equal to if you want, but you'll have to divide across by 3. You'll be leaving yourself with fractions if that's what you do. So I'm going to go with x equals to minus 5 minus 3y. And now what I'm going to do is I'm going to now sub that back in my curve. I'm going to sub that value of x into the equation of the curve. Now I'm bringing that down, which is 2x squared plus y squared equals to 41. And I'm substituting in 4x minus 5 minus 3y. And don't forget though that that has to be squared. Then plus y squared equals to 41. Now the reason for this is, you can hopefully see now, is that my equation here is just in terms of y. So I've gotten rid of my second variable. It just has one variable in it, the y value. So let's see how that brings us. Now be careful here. We need to follow our rules of BIMDAS. So remember our BIMDAS, that you must do brackets and indices being powers, before we do multiplication. So don't go off here now and multiply in that 2, because that is doing multiplication before indices. So just watch for that. So we have to do our squaring of the brackets first. So what I'm going to do here is I'm going to go 2 multiplied by minus 5 minus 3y, and I'm squaring it, so I'm multiplying it by itself. So minus 5 minus 3y. And I'm just going to put them into a square bracket, because that's telling me that I have to do what's inside the brackets first. Then I have my plus y squared equals 41. Multiplying in now these square brackets, it's first term by second bracket, so it's minus 5 multiplied by minus 5 minus 3y. And then it's the minus 3y from the first bracket times the second bracket. And I'm just going to make sure that I enclose them in those square brackets. And then it's plus my y squared equals to 41. Tidying up now inside the bracket, we are going to get minus 5 multiplied by minus 5, which is giving me positive 25. And then I'm going minus 5 multiplied by minus 3y, which is giving me positive 15 y. I'm now doing the same again. I'm going minus 3y multiplied by minus 5, which is giving me positive 15y. And then I'm doing my final jump here, which is minus 3y by minus 3y, which is a positive 9y squared. And then we close off our square bracket. And make sure we put back in our plus y squared equals to 41. Tidying up now inside our square brackets, that leaves us with 2 bracket. I'm going to put the 15y and the 15y together to get 30y. So that's 25 plus 30y plus 9y squared plus y squared equals 41. I've tidied it up as much as I can. Now I'm coming to the part of my BIMDAS for multiplication. So I'm multiplying in this 2. So 2 by 25 is 50. 2 by 30y is 60y. And my third jump is 2 multiplied by 9y squared, which is a positive 18y squared. Now, don't forget that I have to include this positive y squared, which is giving me a plus y squared equals to 41. Tidying up that left-hand side of the bracket, of the equals, it's giving me a 50 plus 60y plus 18 plus 1 is 19y squared equals to 41. I'm now going to move over that 41 to the left hand side, or subtract 41 from both sides, in other words. So that's giving me 50 plus 60y plus 19y squared minus 41. And now I have nothing on the right hand side of the equals, so it is equal to 0. And I'm now going to group the 50 with the minus 41. So 50 minus 41 is positive 9. So that's giving me 9 plus 60y plus 19y squared is equal to 0. I'm going to just put that in order of the highest power first. So that's giving me 19y squared plus 60y, and we always finish with the constant, which is my plus 9 is equal to 0. And I'm leaving myself with another quadratic equation. So you can again use your guide number, your minus b quadratic formula. I'm going to do 2 brackets here. So the 2 numbers to multiply to 19, I have to use 19 and 1 because it is a prime number. So the only two numbers that multiply to 19 are 19 and 1. And the factors of 9 are only 9 and 1 and 3 and 3. So trial and error there doesn't take too long, but I have to get to positive 60 and positive 9. So they have to be plus, and it is 3 by 3. So 3 by 3 is 9. And then I solve that. So I get 19y plus 3 is equal to 0. 19y is equal to negative 3 when I move over the 3 or take 3 from both sides. So that finally gives me y is equal to minus 3 over 19. And my second value is 1y plus 3 is equal to 0. That means that 1y or y is equal to minus 3. Now, we don't accept both values because look at the question. The question is saying where x and y are elements of z. Z, we know, are our number systems for integers. And integer numbers are minus numbers, 0, and positive numbers. But they must be whole numbers. So I can't include fractions in my integers. So I'm ignoring the minus 3 over 19, the fraction, the rational number. I'm only accepting y as minus 3. So therefore, y is equal to minus 3. Now, if you want to check that, what you need to do there is you need to sub that back in to your original equations, and you should see that minus 3 is our only solution there. So we're not finished. We've only now found the value for y. Now we need to go off and find our value for x. So now find the value for x. And if we come back up here to the left hand side, look what we wrote down x as. We said that x is equal to minus 5 minus 3y. That's what we manipulated x to be. And all I have to do here now is I need to substitute in my answer that I got for y, which is negative 3. So I'm subbing in my answer for y, which is minus 3, in for y. So it's minus 3 multiplied by minus 3 here, really, is what it's asking us to do. So x is equal to minus 5 minus 3 by minus 3 is a positive 9. Minus by minus gives me plus. So x is equal to positive 4. And that's it. So therefore, my answers are x is equal to 4 and y is equal to minus 3. And again, we're only taking the negatives and positives for x and y because the question said where x and y are elements of z, integer numbers. That is question 3 done out. Let's have a look at our final question, question 4. So this question is asking us to solve the following equation. An equation, as we know, is something with an equal sign. So they're asking me to solve the equation x plus 1 over x equals 10 over 3. Now I'm going to just put my x as a fraction. I'm going to put it over 1 because I now want to look at 3 fractions. And in order to simplify the fractions, I need to get a common denominator. So to add fractions, I need to have them with the same denominator. So my common denominator on this question is, easiest way to get common denominators basically is by multiplying the denominators. So 1 by x by 3. That will always give you a common denominator. Common denominators don't have to be the lowest common denominator. So 1 by x by 3 is giving me 3x. So I'm going to now rewrite my 3 fractions with my common denominator. So I have a fraction over 3x plus my second fraction over 3x equals my third fraction over 3x. Now I think to myself, each fraction, how did I make the new denominator? So how did I get from 1 to 3x? Well, I multiplied 1 by 3x. So that means that in order to keep these equivalent, I need to multiply the top or the numerator of this particular fraction by 3x. So I'm scribbling in or just noting I'm multiplying the top by 3x. When I come to the middle fraction, how did I make this x become 3x? Well, I had to multiply it by 3. So that means I'm going to multiply the top or the numerator also by 3. So I'm just going to write in and multiply by 3 here. And my final fraction, How did I make the 3 become 3x? Well, I multiplied it by x. So that means I have to multiply the numerator also by x because I have to keep them equivalent. And when I tidy that up, I'm going to multiply the 3x by the x first of all, which is giving me 3x squared over 3x, plus 3 by 1, which is 3 over 3x, and then 10 by x, which is giving me 10x all over 3x. Now you can see here now that we have the same denominator for all three fractions. So something over 3x plus something over 3x is equal to something over 3x. So we can now drop the denominator because we have them all equal to each other. Look at the symbol in the middle, which says that they have to be equal, which they are. So all I have to focus on or worry about here now is the numerators, the top of the fraction. So I basically just have to solve 3x squared plus 3 is equal to 10x. So I'm ignoring the denominators because they are equal. There's an equal sign in this question. I'm just going to rearrange my quadratic here. I'm going to make a quadratic out of it. I'm going to move over that 10x or subtract it from both sides. So it becomes 3x squared minus 10x plus 3 is equal to 0. I'm now again going to solve using guide number, 2 brackets, minus b quadratic formula. I'm going to do the quick way here with the 2 brackets. So 3x multiplied by x are the only factors to get me to 3x squared. Close my bracket, equal to 0. Only numbers that multiply to 3 are 3 and 1. So trial and error will figure it out for you, but I'm putting a 1 in the first bracket and a 3 in the second, and multiply to positive 3 and get to a minus 10, so these must be negative solutions. And I now just solve that. So I take my 3x, subtract 1 is equal to 0, 3x is equal to positive 1, x is equal to dividing both sides by 3, so I get x is equal to a third. And my second value for x is x minus 3 is equal to 0. Move over the 3 or add 3 to both sides, which is x is equal to 3. So therefore, solve the equation. My answers are x is equal to 1/3 and x is equal to 3. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.